In this video, we will look at solving multi-step equations. By the end of the lesson, you should be able to solve multi-step linear equations in one variable. First, let's take a look at the parts of an equation. We know that this is an equation, first of all, because we have an equal sign. This lets us know that we are working with an equation. We also have other parts, including each of our terms. These are our different terms within our equation. We have different types of terms. We have terms with variables and terms without variables. In the terms with variables, the number here we call the coefficient. That's the number that's with the variable. Any number we have that does not have a variable, we call a constant. Within our terms, we have like terms. When we look at an expression or an equation, and we have like terms, they are ones with, if we have like terms, we have terms with an x. So here 3x and negative 6x would be like terms. They both have an x. 3 and 6 are both coefficients. Our other like terms would also be our constants, negative 4 and 2. Negative 4 and 2 are also like terms within our equation. And because we have an equal sign, the whole thing is an equation, but we can also split this up and see that we have an expression on one side of our equation. An expression would occur before we have an equal sign. An equation is with the equal sign. Now let's take a look at what we're going to do with this information. We have two different processes that we can approach with. We can simplify an expression, which just means we are going to combine the like terms that we see. So if we have an expression, we're just looking to simplify it and make it into as least amount of terms as we can. We can also solve an equation. Remember, if we have that equal sign, we can find the missing value of the variable. When we have that equals equation, we can find the missing variable. Let's look at some examples. First, we're going to simplify each expression. So notice here in number 1, I do not have an equal sign. So I'm not looking for the value of x. All I'm looking for is to simplify it into the least amount of terms possible. So first I'm going to look for like terms. Remember here when I'm looking for like terms, I want numbers with variables and numbers without variables. So here I have 3x, which I'm going to put a box around, 3x. And what also looks like it, my negative 6 here also has an x, so I'm going to box that in as well. Notice how I boxed in the negative sign as well. I want to put in the box with the sign so I know what operation to do. My other like terms, I have constants, negative 4 and positive 2. So now when I combine my like terms, I look at 3x minus 6x. 3x minus 6x, which gives me negative 3x. I subtract the coefficients that are in front of the variable. Now I look at my constants, negative 4 plus 2, which is negative 2. I'm going to put these two together into one expression, and I have negative 3x minus 2 as my simplified expression. I know I'm done when I have no more like terms. I can check this. There's no other terms that have an x, and there's no other terms that have a constant. My expression is fully simplified. Let's take a look at another example. If we look at number 3, we have some like terms and we have some constants here that we want to look at, but first we notice we have parentheses. If you have parentheses, we want to use what we talked about in our properties notes about the distributive property. So I want to first distribute my 3 to both terms. I need to do that before I can combine any like terms. So when I distribute my 3 times 2 gives me 6. 3 times negative c, remember there's a negative 1 here. 3 times negative 1 is negative 3c minus c. That minus c just comes down. The 3 does not get distributed to the negative c. It only just gets brought down. Only the things in parentheses get distributed to. Now I'm going to look at my like terms again. I see I have a term here, negative 3c, and another term with a c, and my constant 6 by itself. So I'm going to combine negative 3c minus c. Remember, there is a negative 1 here. When I combine like terms, remember I have negative 3c minus 1c is negative 4c. And then I just have my 6. So when I combine them together, I have negative 4c plus 6. Again, I check to make sure that I have no more like terms, and I do not. I just have my c term and my constant term, and I am done simplifying. If you look below on your page, we're going to look at solving equations next. So in these examples, notice that there is an equal sign. Now we are looking to solve the equation and find the value of the missing variable. When we're finished, we're going to check our solution using the substitution property we've talked about. So we're going to follow the same steps that we did before. If we have distributive property, we're going to do that first. We do not have that here. Next, we want to combine our like terms. So I notice I have d as my variable, and I have 2 terms with a d in them. So I'm going to put a box around them first. And I just have my plus 4. That one does not have a like term on that side of the equal sign. So when I combine these, I have 9d minus 2d, which is 7d, and I just have my 4. When I write it all together, I have 7d plus 4 is equal to 32, and I draw my line down the equal sign. Notice that I have simplified. Now I've simplified my expression, and I can write my full equation out. Now my job is to solve the equation and figure out what the value of d is. So notice when I start solving my equation, I have a plus 4. I'm going to do the opposite using my subtraction property of equality, subtracting 4 from both sides. My 4's will cancel. Plus 4 minus 4 gives me 0. 7d is going to be equal to 32 minus 4 is 28. My last step here is multiplication, 7 times d, so I'm going to divide both sides by 7. My 7's will cancel. d is equal to 4. Now I want to check my solution. My equation said that I got d is equal to 4. So let's just make sure that that's true. So I'm going to go back to my original equation and substitute 4 in for d. 9 times 4 plus 4 minus 2 times 4 equals 32. 9 times 4 is 36 plus 4 minus 2 times 4, which is 8, should be equal to 32. Well, 36 plus 4 is 40. 40 minus 8 is 32. And that one is correct. The solution of d equals 4 does work for my equation. Let's look at another example. Again, here we want to check for distributive property first, and in this example, I do have that. I see my parentheses, and I know that I need to distribute my 3 to both terms first. I need to do that before I can combine any like terms. I must distribute first. So I'm going to keep 2w plus 3 times w is 3w. 3 times 4 is 12 equals 27. Now I want to combine my like terms. Again, I look for here 2 and w. I have another term with a w. That's my 3. and 12 does not have a like term on that side of the equal sign. So when I combine them, 2w plus 3w, I add the coefficients, I get 5w plus 12 equals 27. Again, I'm going to draw my line down my equal sign, and I want to solve for w, so I want to get rid of my 12 first. When I see plus 12, I want to do the opposite. I want to subtract 12 using my subtraction property of equality. 12 minus 12 goes to 0, so they cancel. 5w is equal to 27 minus 12, which gives me 15. Lastly, when I want to get w by itself, 5 times w, I'm going to divide both sides by 5. My 5's will cancel. W is equal to 15 divided by 5, which is 3. Let's look at just two more examples. In this one, we notice we have parentheses, but we also have a fraction. So there's a few ways we could look at this one. What we want to do is get rid of our fraction. So when we get rid of our fraction, we want to multiply by the reciprocal. We saw that word reciprocal when we talked about our inverse property. We want to take the inverse of 3 over 2, which means I flip and I multiply by 2 over 3. But what I do to one side, I must do to the other side of my equation. So when I multiply by the reciprocal, my fraction on the left side goes away, and I'm left with 3x plus 5 is equal to. Now I look here, I don't have any like terms that I need to combine. Both 3x and 5 are as simplified as they can be. So now I can just solve for x. So again, I want to get rid of my 5 first. When I have plus 5, I want to do the opposite, which is subtract 5. 3x is equal to minus 4 minus 5, which is negative 9. My last step is to divide both sides by 3. X is equal to negative 9 divided by 3, which is negative 3. And in this example, we notice that we have two fractions. We have two fractions. We have our variable up in the numerator here, and I want to solve for x. So we're going to use our reciprocal idea again to solve for x. So for this, you can really choose 5 or 3 to get rid of first. I'm going to choose 5. So because 5 is in the denominator, I'm going to multiply both sides of my equation by 5. What this does is cancels out my 5's on this side, and I'm left with x minus 2 is equal to, when I multiply on this side, when you multiply fractions, I multiply straight across. 5 times 2 is 10 over 3 times 1, which is 3. I can write any whole number over 1 to help me multiply straight across. Now I still have my 3 in my denominator. So I want to do the same thing, but I want to do that with my 3. I'm going to multiply both sides by 3. Over here, it's going to cancel out just like my 5's did on this side. So my 10 is what's left. On this side, I'm taking 3 and I'm multiplying it by 2 terms. So when I do that, I need to put parentheses around them. Now when I see parentheses, I need to do my distributive property. My 3 gets multiplied by both of those terms. I'm left with 3x, 3 times x, minus 3 times 2 is 6. And now I'm going to solve this equation just like I've done before. I see subtraction with my 6, so I'm going to do addition. My minus 6 plus 6 cancels. I get 3x equals 10 plus 6 is 16. Lastly, I'm going to divide both sides by 3. X equals 16 over 3. We've reached the end of our video for today. Please bring your notes to class so we can finish going over some of these examples and practicing in class.